Graphing linear inequalities. In this video, we're going to graph a linear inequality in two variables. Before we begin, I want to go over just some basics of sketching the line of an inequality. So if your equation is written with an inequality symbol of less than or equal to or greater than or equal to. In other words, it has a line underneath there that or equal to added component, then you will always sketch or draw a solid line. And when you have just the less than or greater than without the line underneath it, no or equal to added to it, just the less than or greater than, you will sketch a dashed line. So in the example here, you see this equation here is just the greater than, no line underneath. That is why you have a dashed line sketched. And here you have the or equal to added to there, that line there, which indicates you sketch a solid line. Now, when you are graphing linear inequalities, you are going to graph and then shade. In terms of which side you should shade, let's get into that. So if the equation is in what we call slope-intercept form, meaning it's solved for y, if it is y is less than or less than or equal to, any type of less, it means that you are going to shade everything below the line or below the graph there. And if when you solve for y that you have greater than or equal to, then you're going to shade all the points and the region above the line or above the graph. And that's the boundary method. So in this example, we're asked to graph this linear inequality, and as you can see, it is in slope-intercept form. And when it's in this form, we can easily determine what region we're going to shade. Recall, when it's greater than, that means you're going to shade upper. But before we begin that, we need to first sketch our line first. So let's go ahead and graph this line. When you have it in slope-intercept form, recall that step one would be to plot your y-intercept. In terms of an ordered pair, it is located at 0, -3, and then from that point, you're going to use your slope to rise and run to your next point. So again, the y-intercept is 0, down 3, so let's go ahead and plot that first. Now, once you get that point from there, you're going to rise up 3 and run 2, and that will take you to your next point on the line. So I'm going to rise up 3, run 2, and there's my next point on the line. And what type of line am I going to draw through those 2 points? Is it going to be dashed or is it going to be solid? Well, if you said dash, you are correct, because anytime you have the symbols with no line underneath, you are going to shade a dashed line. And now that we have the line, we can use the boundary method to determine which region we're going to shade, whether we're going to shade above the line or whether we're going to shade below the line. So because you have here the greater than, it means that we are going to shade above the line, and that would be your region there toward the left. And there you have it. We have graphed and shaded the inequality. Another method is called the test point method. With the test point, we're going to use the test point 0, 0. And when we substitute that test point into an equation, if it leaves us with a true statement, we will shade that side. However, if it leaves us with a false statement, then we will not shade the side where the test point is located. So let's do an example with that. Okay, let's graph this lines. Here we have a line in standard form. So I'm going to go ahead and use what we call the x and y intercepts of a line. And that's where you let one variable be 0 in order to solve for the other variable. So we're going to start by, I'm going to let x be 0, means remove the x and replace it with 0. When I do so, what I'm left with is 2y equals 6. Next step is to divide by 2 and y equals 3. So what's my ordered pair? Well, remember we plugged in a 0 for x and what we got out for y was a 3, so 0, 3. Now we're going to do that again, but this time we're going to leave x alone. We'll let y be 0, so remove the y and replace it with 0. And we can readily see that x equals 6. So our ordered pair, in x's place, we have a 6. In y's place, we have a 0. So my ordered pair is 6, 0. Let's go ahead and plot these 2 points. So the first one is 0 and up 3. The other one is over 6 and stay at 0. And what kind of line are we going to sketch through those points? Well, if you can see, the inequality symbol tells us that we are going to sketch a solid line through those 2 points. And now our next step is to determine which side we're going to shade. So here we're given an equation in standard form, and recall, when an equation is in any other form, you can use what is called the test point method. So the test point method is using the test point 0, 0. Which is located right at the point of origin where the x and the y axis intersect. And so what that means is, if I plug that ordered pair of 0, 0 in and I get a true statement, that means I'm going to shade below the line, because everywhere where that test point is true. However, if I plug the test point in and I get a false, then that means do not shade the side where the test point is. Then that means shade the opposite side. Okay, so if you get a true, you shade the same side that the test point is on. If you get a false, do not shade the side the test point is on. So let's go ahead and plug those values in, removing the x, removing the y, replacing them both with a 0. So what we're going to have is a 0 on the left side and a 6 on the right side. Now let's read this statement. This says that 0 is greater than 6. That's not true. Let's see if the other one is true, that 0 is equal to 6. That's not true either, because 0 is not the same as 6. Since both are false, that means this is a false statement, which means that my test point area, everything below along with that test point, is false. Never ever shade the false side. Always shade the true side. So by default, the opposite side is your true side, and that is the side that you would shade.